and welcome to Cycle 1 Science Videos. This one's for week 2. This week we're running 2 experiments. The first one's going to be a lot of fun. It's called Telegraph lines. It's number 54 in the Van Cleves. So what are your supplies? You need some string. This is the type of string that I used. And I cut 4 pieces. So CC Livermore tutors, you're going to have 4 pieces about my arm's length in your box. And how you run the experiment will depend on how old your students are, how many kids you have in your class, and how many parent helpers you have. And we'll talk about that in a moment, but let's just show the experiment so you remember what it is. So I'm using chairs because it's just me for the experiment. So we have 2 people holding on to the end of the string, pulling it nice and tight, or we can tie it on to some stationary objects. If you do, just keep in mind from a safety perspective, we want it to be high enough so no one accidentally trips or strangles or limbos under it during science time. All right, so the idea is that we're going to determine if the spider senses can help it in determining the size of an intruder on its web. How big is lunch, right? So the process is that one student will hold their hand, I think they should face away from the other end, hold their hand on the string and close their eyes so that they can really put their sensory experience into what they're feeling. And then you as the tutor or another student is to pluck the string firmly and gently. And with your hand on the string to feel the vibrations, you can sense the difference between a large vibration and a smaller vibration, and that's the idea. So while it seems like a simple experiment, I think it'll be a lot of fun for the kids, and let's remember what our objectives are. Our objectives are to help our students with the grammar of science, and the grammar of science is going through the scientific method and walking them through that, making sure that they memorize it. It's also improving their ability to observe. And how do we do that? How can we as tutors and directors improve our students' abilities to observe? We're going to model for our parents by asking questions. What do you feel? What do you see? What do you think the purpose of this is? Why do you think it was designed that way? What do you think this is used for? Those sorts of questions. Who, what, when, where, why, how? Those are really great questions to get your kids thinking. The other idea is to make sure that they're using all of their senses to observe. When you isolate one sense by closing their eyes and just having them touch, that helps to isolate that sense of touch and really does improve their ability to observe. And of course, finally, what they observe through their eye, sketching down on paper. That's why for CC Livermore tutors, I really do encourage you when applicable, especially like for the second experiment this week, to have them sketch where possible, because that helps them to improve what they see, to really focus on one sense, the sense of what they're seeing, and then trying to imitate it and drawing and observing carefully. So that is the experiment and how to run it. You can have 2 parents holding on to it, or you can divide your class into 2 teams of 4 and have your students holding on and each of the students taking turns at each of the positions, whether it's plucking or touching or holding, just rotating them through that way. So it's a really simple experiment, but a lot that you can do with that sense of observation. Let's talk about the second experiment, which is belly up. Number 56 in the Van Cleves, and we're trying to determine why a fish floats to the surface of the water after dying. What causes a fish to float belly up? Now, I really want to encourage you, while there's things on CC Connected, I'm going to encourage you to use your Van Cleves as a resource. Keep your life simple, and you can bring in that Van Cleves book into class and read right from the Van Cleves. I will be honest with you, this experiment perplexes me a little bit. I just find it to be a little difficult, not in execution, but in explanation. So make sure you are reading about the bacteria and reading about how the air expands in the belly and pushes the fish up to the surface of the water. But let me show you your supplies. You're gonna have a cup, a baggie, a straw, a bowl, and a container of water. The first class will fill up the bowl with water, and the rest of the classes will just use the water that's already in there, because at CC Livermore we rotate through our science location. Okay, so directions. We're going to open our bag. This one is run as a tutor demonstration, so each student is really just going to be observing. We're going to be having them think of good questions to ask and good observations and ideas on what things that they could draw. If you, the last time around in cycle one of our tutors brought in a dead fish that they had opened up so that you could see the parts on the inside dissected a little bit. If you want to do that and you're at CC Livermore, I welcome it. If you're on another campus and you happen to have some fish around, or you want to run to the store and grab one, it's a really good way for those students to get hands-on and observe more closely. But here's what we're doing. You're going to pour half a cup, somewhere of that nature, water into this baggie, zip it up most of the way, insert your straw, and fill it with air. There you go. So now you have a baggie with air in it, and this is to simulate our dead fish that has had its bacteria producing its gaseous waste. Then when the bowl is filled up with water, the experiment is simply to place the baggie of water, and I like to place it water side down so that they can see the movement of the baggie, and I don't know that you'll be able to see this on the video, but you place the baggie in the water, and when you let it go, it tends to tip over so that the air it lays flat this way with all of the air at the top, or even, I guess it could stand up this way. No, it tends to turn over with all of the air at the top. So this is the extent of that experiment. So think of good who, what, when, where, why, how questions. How is this useful? Where can we apply this in other ways? What can we, I don't know, what can we do with this information? I don't know, ladies. That's all I've got for you on this week. I hope that this demonstration was helpful to you, and I will see you on Friday.